Okay, you guys on this problem number 16 on 3.2, you're given this table right here. Okay? Now, first of all, you guys, you need to stop talking. Okay? You're supposed to find the numbers that go between these whole numbers right here first, aren't you? Okay? What did we do to 4 to get 16? We times it by 4, right? So what's this next number going to be? What's going to go under 2 right here? 64. What's going to go into 3? I know it doesn't go that far, but 4 times 64 is 256. I just took it out a little bit further. So here we have this pattern where we're multiplying by 4 each time, but I'm supposed to get the number that goes halfway in between there. How do I get that number?
4 by 16 and then take the square root of that.
Okay, 4 times 16 and take the square root of that number?
Yes.
So for example, to show me. 4 times 16 is 64, and the square root of 64 is 8. So you thinking this is 8? If that's the case, are we doubling each time?
Yes.
That would work, actually.
But wouldn't it be like, since it's exponential, wouldn't that be taken half and it'd be like, it wouldn't be round anymore, it'd be like...
Yeah, let's see. Well, it's doubling each time, so it'd still be it'd be an exponential function.
It would be round, it would be like this.
No. I mean, if you took every single point, it would be round. If you're taking a point here and a point there, yeah, you're connecting them, and you're going to get something like this. But if you take all the points in between, you would get a round curve. Because this is geometric. It's exponential because you're doubling each time, right? So what goes on this next one, you guys? 32. And what's the next one? 128. Does that fall in line with that pattern? Yeah. Can you say that again? Well, 4 root 4. So root 4 is, yeah, root 4 is 2. 2 times 4 is 8, right? So if I go root 4 times this, root 4 is 2. 2 times 8 is 16. Root 4 is the same thing as 2, right? So you're just multiplying by 2. So it's the same thing. Okay? All right, what other things you guys, what other problem right there? Let's go to 17. I want to make sure you guys understand this. Okay, if we look at 17, you're given another table like this. So in this case, we have x and y right here. And we have 0 and 5. And we have 1/2, and we have a under there, and we have 1 and 15. Now this one's a little bit different, isn't it? 3/2. And 2. Okay? So if we're looking at this one right here, I got to times 5 by something to get that, and then I got to times it by something else to get 15. What do you think? Is it 3? Is 3 their number? Well, I know I times by 5 times 3 is 15, right, to get that number. So if I times 15 by 3, what should I get for 2 right there? If I follow that pattern. Okay, 45. Is this what you guys are getting on those? Okay, so what about the in-between numbers right here? What am I timesing from here to here? And from here to here? Get those. Think about this. I have got to times 5 by something, and I got to times that 5 and that other something by something to get 15. And I know that 5 times 3 is 15, right? So what is that number? What's that number that I'm multiplying every single time to get the next number? It's not 3. 3 times 5, that's right, root 3. Because 5 times root, so this number right here is going to be 5 root 3, right? Now, if I times by root 3 again from here to here. Square root of 3 times square root of 3 is square root of 9, which is 5 times 3, which is the 15, right? So this one is 15 root 3. Now, if I times root 3 times root 3, I get 3. 3 times 15 is 45, right? So the answer, you're multiplying by root 3 each time. A root 3. Do you understand that? Okay? Okay, you're multiplying by root 3 each time. Okay? Yeah, we did that last time. So what is it on 5? What on number 18? What are you multiplying by on that one? Oh, I just did that one, huh? 17. I thought I was doing 17. I did 18. What are you multiplying that one 17 by? Number 4 to get the next number. 4 times 8 is 2, right? So you're going to do the square root of that. 4 root 2. So root 2 is the number you're going to multiply by each time on 17. Okay, if you're done, turn it in. Quickly, we got to hurry. Okay, we're going to look at number 15 and 16 on 3.3. All right, how many of you guys got number 15, by the way? Anybody get it? Okay, well, what did you do? Just explain what you did. Branson? Is that order of operation, guys? Should I times 50 times 2 first? Or do I raise 2 to the x plus 2 power? How do I do that? What would I write? What would this... That is exactly right. You guys remember that rule? Think about this, you guys. If I have 2 to the x times 2 squared, remember the rule is if you're multiplying the bases are the same, you're multiplying, you can add the exponents. 2 to the x plus 2. Remember that rule? It's the rule of exponents we've talked about. You guys learned that actually last year. We've kind of reviewed it this year. So we have that now. If I'm going to simplify that, what order do I go in now? Okay, I got to do exponents first. And now, I can't go to the x because x is a variable, right? But what's 2 squared? 4. And what's 4 times 50? Okay, 200. So it's 200 times 2 to the x power. Now, I cannot multiply 200 times 2 because the order of operation says I have to raise 2 to the x power first, and I don't know what x is, so I have to leave my answer like that. Does that make sense? Okay. Let's look at number 16. Does everybody have that one? Okay, number 16. What can I do right here? What's this asking? Determine whether all 3 expressions in each... Oh, we got 2 more parts to number 15, don't we? We got to see if these are all equivalent expressions. So 25 times 2 to the 2x plus 1. Okay, so if we're using the same strategy right here, what would I write? Times 2 to the 2x times 2 to the 1 power, which we can just leave as 2, right? Okay, 25 times 2 is what? 50 times 2 to the 2x. Can 2 to the... That's a good question. Christian asked, can 2 to the 2x be what? It can be 2 times 2 to the x, but, or we can just write 4 to the x like that. That's a better way to write it. 50 times 4 to the x power, because 2 squared is 4, right? Now, can I multiply 50 times 4 together? No, because I have to have order of operation. Grant, go to your seat. Okay, chair's gone, guys. Put it over here. Let's go. Let's go. Go back to your seat, Grant. Hurry. Let's go, Kurt. Put that away. Okay. Here we go. Next. 50 times 4 to the x. What do you think about that, you guys? The third part of that one. What do you think? Yeah, we can't simplify it anymore. It's the same as that one, but it's not the same as that one right there, right? So that one, they're not all the same. So the first one is different. Now you guys are supposed to justify why or why not they're equivalent. If you show your work, you're justifying that. Okay? All right, number 30. We have 30 times 1.05 to the x power. I mean number 16. 30 times 1.05 to the x power. Now, we have 30 times 1.05 to the x power. Can I simplify that? Is it simplified? Okay, so let's go write the next one down. 1.05. We had 30 times that, right? 30 times 1.05 to the 1/7 power. And that's all raised to the 7x power. What do you guys think right there? Yeah, if I have a power to a power, I can times 1/7 times 7x. What is that? It's 1x, all right? So this is going to come out to be 30 times 1.05 to the x power. So far we're the same, right? This first one's the same as the second one. Okay, let's go to the next one. 1.05 to the x over 2 squared. Okay, what do you think on that one? X, yeah, times the x over 2 times 2, and they cancel out, right? 2 divided by 2 is 1. So I'm going to get 30 times 1.05 to the x power. So all three of those are the same, right? You getting the idea of these, you guys? We have to understand rules of exponents if we're going to be able to get the rules of exponents with rational exponents. Okay, what other number did you ask, Jacoy? Okay, let's look at 28. 28 has r, help me out with that. Does that say r to the 5th? R to the 5th, and s to the what? 3rd, to the 2nd. Okay. All right. Hey, guys, we have, let me show you this way. This is probably good for you guys to understand. If I wrote it in, remember, everybody turn to the front. I want to list the factors. What would I list the top factors be? In fact, I want everybody to do that. 30 seconds in your group. I want you to list the top factors and the bottom factors. Go ahead and do that. 30 seconds. Even if you've done this problem already, I want you to do that. You guys, what is the top list of factors going to be? Times S, times S, times S. Okay. What is the bottom list of factors going to be? Now how many of you know how to do this? Could you do it now? Okay. It's pretty easy when you list out the factors. Those cancel out. Those cancel out. Those cancel out. And then what am I left with? Wait, say that again? R4. What does R4 mean? R to the 4th. Times S. And there's my answer, right? Okay, do you understand how to do something like that? Okay? All right. I've had those before. Okay, you guys, do you want me to do one more on 18 through 29? I'll do one more. Did we do 29 the other day? Yeah. Hey, 27, you got a power to a power. I'll do that one. 27, we have 3 to the 4th to the 6th over 3 to the 7th, right? Now, this 6 is telling me to multiply 3 to the 4th by itself 6 times, right? However, the faster way to do it, power to power, what do you do with them? Times them. Well, what's 4 times 6? 24. And then we have over 3 to the 7th, right? Now, I could list out 24 threes on the top and 7 threes on the bottom, and then what would I do? Yeah, well, yeah, I just cancel the threes out. So what would be left if I did that? 24 divided by 7? That's right, 24 minus 7. Because think about this. If I put 24 threes on the top, 7 threes on the bottom, 7 threes on the bottom are going to cancel with 7 on the top. You're just minusing, right? So you guys, this is equal to 3 to the 24 minus 7. Remember, dividing, if the bases are the same, you're dividing, you subtract exponents. So that's going to be 3 to the 17th power. And then you can put that in your calculator and figure out what 3 to the 17th power is. Okay? All right, when is this assignment due? Next time. Okay? This assignment is due next time. No. I just want to really review this really quickly. I need to make this a little bit bigger so you guys can see it. It would be easier if I did what? Okay. Right here, you guys, let's go through this together. It says, now that Tia and Tahani know that a to the m over n power, I don't know if you guys can see this, a to the m over n power is equal to the nth root of a to the m power. We all know that, don't we? Does everybody understand this? Look at this. Do we understand that? Okay. They are wondering which form, radical form or exponential form, is best to use when working with numerical and algebraic expressions. Okay? So Tia says she prefers radicals since she understands the following properties for radicals, and there are not too many properties to remember. If n is a positive integer greater than 1, by the way, this number right here, you guys, does that say m right there, you guys? I can't see it. Okay. I think that's supposed to say m. If n is a positive integer, you guys, this number right here, the index, or the bottom part, it would be this number right here and this number right here, always has to be a positive integer. I want everybody to write that down in your notes. Take out your notes. N always has to be a positive integer. Okay? And both a and b are positive real numbers. Okay? Guys, the radicand inside here, a and b right here, those numbers always have to be positive numbers for this to work. If they're negative numbers, we get imaginary number solutions, and we'll talk about that at another time. Okay? So A and B also have to be positive numbers. This is the nth root of a to the n. The nth root of a times b equals the nth root of a times the nth root of b. N has to be positive. Oh, let me write it one more time. A to the m over n is equal to the nth root of a to the m power. N has to be positive. Let me say that again. N has to be a positive integer. I mean a whole number, like 1. It actually can't be 1 either. N has to be a positive number greater than 1. So 2, 3, 4, 5, 6, 7, so forth. Well, no, it can't be 1 because the radical already says that it's going to be a 2 or higher, the n. Okay? So right here, yeah, I mean, no, can't. Okay, A and B have to be positive numbers. You can't, and they can be decimals, but A and B have to be positive numbers. They can't be a negative number. Okay, so does everybody have that now? Now, it's just reviewing some rules of exponents. I want you guys to all write these down. Rules of radicals, first of all. Everybody put something up there that says rules of radicals in your notes. And the first rule of radical, I don't know if you guys can see this, so I'm going to rewrite it right here. It says if you have the nth root of a to the n, it's equal to a. I want you to discuss in your groups why that is true. And the nth root of a to the n power. In other words, both these numbers are n. That's n, that's n. Why is that equal to a? In your groups, discuss it. Then I'm going to call on someone. I need to justify it mathematically, though. So think about how you would justify it mathematically. We need to know more than just that's how it works. Okay, I'm going to ask this table right back here. Do you guys come up with an explanation of why? Why? Okay, and you guys got it. That's it. But I want to do it another mathematical way. Alex's group. Yeah. That's what I want you guys to see right here. Because if this is the nth root of a to the n, we can rewrite it as a to the n over n power, right? Well, what's n divided by n? So it's a to the 1 power, which is just a, like Alex said. Got it? That's why it works. Now, all that is saying, you guys, if I have anything, like if I have the third root of 5 to the 3rd power, what's that going to be equal to? 5. Does everybody understand that? Now that's, you guys, I'm telling you what, when you take math classes, if you know this is going to save you a lot of time. Because this comes up all the time. It comes up in all my other classes, and students don't always remember this. The ones that do get it done really fast. The ones that don't, they're struggling with it. And it's a simple rule. If you're taking the nth root of something to the n power, you're just going to get that back. Okay, the next rule states this right here, that if you have the nth root of a times b, that's equal to the nth root of a times the nth root of b. I want you to put that into English words and discuss that in your group. Put it into English. I'm going to call in a group to give me that answer. Okay, Justine's group's going to give us. Can everybody listen to Justine, please? That is exactly right. Okay, that's one way to explain it. That was more of a mathematical explanation, which is better than what I was saying to do. But she was saying that before when we had the a to the 2 plus 4 power, we could write it as a squared times a to the 4th, that thing. Okay, this is kind of the same idea, but with radicals. Okay, anybody else want to say anything about it? This is kind of what I was wanting you to get at right here, is that if you have the nth root of two numbers being multiplied together, you can separate it into two different radicals. That's what I wanted you to understand. You can separate it. Now, this is an important rule, too. If you know this rule, this will help you out a lot in future math. Okay? On the ACT test, you will see lots of problems that have to do with this, the ACT test. Okay? All right. Okay. So let me give you an example in real. Let's say I have the 4th root of 7x. Well, actually, yeah. I can write this as the 4th root of 7, right, times the 4th root of x. Let me show you where it's more useful. In simplifying radicals. Let's say we had the square root of 24. Well, I know that 6 times 4 is 24, right? So I can rewrite this as the square root of 6 times 4. Now, that means I can separate it into two radicals, the square root of 6 times the square root of 4. And since 4 is a perfect square, the square root of 4 is 2, I can write it as 2 times the square root of 6. That's another way we can use it. Now remember when we were simplifying and I had you guys make the tree diagram, break it down into its prime factors? The same thing, I just did it a different way. This is the way I used to teach it, but not as many kids understood it as well that way, and that's why I went to the other way. But 2 times the square root of 6 is what that would simplify to be, and we use this rule right here to do that. Okay? Now, the last rule for radicals, states this right here. If you have the nth root of a number divided by a number, you can also separate those into the nth root of A divided by the nth root of B. Let me show you a real live example of that. What if I had the square root of 4 ninths? In your groups, I'm just going to give you 20 seconds. Simplify that using this rule. Oops, I had that off. Okay, so we have that rule as well. Now, going up right here, we also, it says Tahanya says she prefers exponents since she understands the following properties for exponents. Now, these are the rules that we've all gone over, but I want you guys to have them in your notes. So I want everybody to write these rules down. I'm going to make them bigger. We all know these already. A to the m times a to the n is equal to what, everybody? A to the m plus n, right? If the bases are the same, we're multiplying, we add the exponents. A to the m times a to the n is equal to what, everybody? A to the mn power. We multiply them. When it's a power to a power, I call that. Most of your textbooks would call it that too, a power to a power. Get a to the m times n. Okay, then the next one. A times b. I haven't really gone over this rule with you yet. If I have two numbers being multiplied together and they're both being raised to the same power, I have to individually raise them to that power. So a times b to the nth. This is totally different than this, you guys. This is not true. This right here is not equal. Let's say I had something like that. Well, let's go to the nth power. This right here is not the same as this right. Put 2 in there. N. Those are not equal. Don't get these two things confused. This is a times b to the nth power. If it's times, you can raise each of them to that power. If it's plus, let's say you had something like x plus 2 to the third power. It's not going to be x cubed plus 2 cubed. It's going to be x plus 2 times x plus 2 times x plus 2. Okay, which means you have to FOIL, right? Okay, doesn't take that long. Okay, but that's what that means. So don't get those two confused. That one right there is not a rule of exponents. I wanted to show you because a lot of students make that mistake. Okay, here's another one. A over b to the nth power. This is kind of like the division 1 with radicals up there. It's equal to a to the n over b to the n. So if you have a fraction being raised to a power, you can raise the numerator to that power and raise the denominator to that power separately. Got that rule? Now you're going to use these rules a lot in the next couple weeks. So you've got to get them down. Okay, the next one. A to the m over a to the n equals a to the, we already know this one, m minus n, right? A to the m minus n power. So when you're dividing, you can subtract the exponents. And number 6 right here says a to the negative n equals 1 over a to the positive n. So if you have a negative exponent, move it to the denominator and make the exponent positive, right? By the way, that goes the other way too. If you have 1 over a to the negative n, that's equal to a to the positive n. So you can write it either way. I want you to write both of these down in your notes. Okay, now, I don't care about that next part. So does everybody have this down? Can I? Huh? Do you have them all down, or can I erase it? Okay, now I want everybody to go to your paper that you have right here. For each, wait. Oh, wait, go back, go to the top of your paper. I want you guys in your groups to read, I want you to read this part right here. And I want you guys to discuss the difference between these two girls, or I don't know if Tahani is a girl's name or a guy's name. Tahani and Tia. I want you guys to compare their two different ways of doing it and discuss it in your groups. I'm going to give you about 2 minutes. Go. Let me kind of explain what they're doing here, okay? Because some of you guys probably aren't following this all the way. But this one where it had the cube root of x to the 8th power, since it's a cube root that we're looking for, they want to separate everything into cubes that they can. Well, 3 plus 3 plus 2 would make 8, right? So they can have a x cubed here, an x cubed here, but that leaves you with an x squared, because 3 plus 3 plus 2 is 8, right? Using the rules of exponents. Okay, so then they separated it using that rule where we can separate the radicals into a cube root of x cubed, cube root of x cubed, and a cube root of x squared. And we learned that rule that if the cube root and the cube, it's a cube root and a cube, so they undo each other and it just becomes x, right? X times x. And that leaves you with the cube root of x squared, which can't be simplified. And so that's what, and then the x times x is x squared, and you get that answer right there. Okay? Now, the other person's method is actually a little bit faster. Okay? She rewrote it as x to the 8 thirds, right? And since, how many times will 3 go into 8? 2 with how many left over? Yeah, 2 and 2 thirds, right? So she separated it into x to the 2 plus 2 thirds. Can you do that? Yeah, you can do that because 2 plus 2 thirds is 8 thirds, and it's all in the exponent. Now, we can use that rule that says, well, since it's plus up there, I can write it as x squared times x to the 2 thirds, right? Using the multiplication rule. And then I can just rewrite x to the 2 thirds as a radical. So x squared times the cube root of x squared. And we got the same answer, right? Which way do you guys like better? Top one or bottom one? If you like the top one better, raise your hand. If you like the bottom one better, raise your hand. Okay? So some of you like the top one better, or if you like the bottom one better. Personally, I like the bottom one better. But there are times I like the top way better, depending on the problem. Okay? But I think rational exponents are easier to work with. That's why we have them, because it makes it easier to work with. Okay, so we're going to go right now. I want you guys to go to this part right here. For each of the following problems, simplify the expression in the ways you think Tia and Tahani might do it. Which one was which? The top method? The top was Tia. The second one was Tahani. Okay? The top method is using radicals. The bottom method is using rational exponents. I want you guys to simplify that. Just do numbers. Just do the first one, the square root of 27 in your groups right now. I'm going to give you a couple minutes. Go. Hey, I saw a lot of you guys do this, right? Let me just show you really quickly. 27 can be written as 3 cubed because 27 breaks, its prime factors are 3 times 3 times 3. Okay, so look right here. I can rewrite this. Oh, hey, I told you wrong because it's not cube root. You had a cube root right there. This is not a cube root, it's a square root. Okay? I I saw the cube on yours, and that's why I thought it was. Okay, so this is the square root of 3 cubed. You guys all know that's a square root if you got that, right? Now, I need 3 to the second power, right? Because this is a square root. So I'm going to rewrite this as the square root of 3 squared times 3. Now I can break them down into the square root of 3 squared times the square root of 3 using the rule that says I can separate them. What is the square root of 3 squared, you guys? What's the nth root of a to the n? A. Okay, so the square root of 3 squared is 3. And this is simplified, so I just write it as 3 root 3. Okay, well hey, you can, if you do it in a different way, that's great. Okay? Okay? Now, here's the other way of doing it. I can rewrite it as 3 to the 3/2 power, right? Because the index is 2. I just changed it to a rational exponent. We've been doing this for a long time now. Changing to rational exponents. You got to know how to do that by now. Branson. That number goes on top, 3. And that number goes on the bottom, 3 over 2. Do you remember that? Oh my gosh. Okay. All right. Branson, I'll get with you. Okay? We'll go over that. Now, 2 will go into 3 how many times? 1 and 1/2 times, right? So we're going to go 3 to the 1 plus 1/2 power. What's 3 to the 1 power? 3 times 3 to the 1/2 power, right? We can read it like that using our rules. And what's the other way of writing 3 to the 1/2 power? Root 3. So either way, I get the same answer. Either using radicals or rational exponents. I want you to see if you can. Now, you guys, the first thing I would do on this one is start breaking it down as prime factors. I'd get it down as prime factors. I want you guys to do the next one. See if you can do that both ways. Okay, some of you guys are getting this down, but you're kind of doing it in your own way in your head, which is awesome. That's what I want you to be able to do. The reason I'm taking you through these steps, and I honestly think it will help you understand it more in depth if you do it that way, so you understand why you're doing things, okay, is to help you get that depth, okay? But a lot of you guys are getting the answers without doing that, and you're doing the steps, you're just doing them in your head. I don't think you realize you're doing that. But let me just show you what they would do, these two methods like. Okay, first of all, what did 32 break down to? No, cube root of 2 to the 5th power, right? 32 breaks down to 2 to the 5th power, right? Yeah, because 2 times itself 5 times is 32. If you break it down. Okay, so here you have this. Now, it's suggesting that we got to break it down into 3s. Well, the cube root of 2 cubed, and then times 2 squared, right? Because 3 plus 2 is 5, isn't it? And then the cube root of 2 cubed times the cube root of 2 squared. Well, the nth root of a to the n is just a, right? So the third root of 2 to the 3rd is 2. And this one right here doesn't break down anymore. I could, if I was writing it as a rational exponent, it would be times 2 to the 2/3. But in this case right here, I'm going to square the 2 and get 4. So I'm going to get the cube root of 4. So 2 times the cube root of 4. Now when I went around, most of you guys had that answer. You just didn't know how to follow these steps. Okay, you're getting it. That means you're getting it. Okay. Now this method, I would write 2 to the 5/3 power, right? How many times does 3 go into 5, everybody? 1 and 2/3 times. So I'm going to write 2 to the 1 plus 2/3. So that's 2 to the 1 power times 2 to the 2/3 power. I could leave it like that, Or I could write 2 times, and since 2 squared is 4, I can write 4 to the 1/3 power if you wanted to make it look like the other answer over here. Okay? Because I could raise it to the top number's power. 2 squared is 4. Huh? Tahani, how many, does Tahani make you more happy, or Tia make you more happy? The tree version works much better? You know what? You guys, if you can skip right to the tree version, do it. This time I'm going to skip the methods. I want you guys to do the next 2 problems and skip the methods that they use. Just see if you can simplify it. Okay, go.